You'll be divided up into groups. I'm going to let you pick your partner.
Thank you.
But the person you pick, you're stuck with. You cannot.
Maria, can I pick?
Hush. You take your hood off. Take your hood off. Jeremiah. You. Jeremiah, take your hood off. Now.
How many partners? Two more or?
You get two. Meaning you only get one person to work with. You're going to be spread out around the room. I don't teach elementary school. Hey, Sue, hush. Shh. Once you've got a partner and you're in an area, you can't work with another group. If I see you talking to another group, all 4 people get zeros. I don't care. It's my rules, my classroom. I get to decide. I don't care. DeAndre, if you don't like it, there's the door. Don't let the doorknob hit you on the way out.
What you mean? Don't let the door hit.
Doorknob sticks out further than the door. Now, if we don't want to be successful, then we need to make sure that we can answer the questions. Okay? So, temperature versus heat. We need to talk about how they're different. Okay? Parts of this I'm going to skip because we don't necessarily. I thought you were leaving. Then sit down and be quiet. So, we need to be able to tell how temperature and heat are different. Okay? And there's some major things that make temperature and heat different today. Now, thermal energy is just another way, first of all, to say heat. Now, I use the word thermal energy because some of us are struggling with the idea that thermal energy is one of the 5 forms that we worked with in the last year.
Why I got no face on y'all?
Because Miss Thornhill thinks it's cute.
Who is that? Is she cute?
She's another science teacher. She would probably say no.
Dr. Phil. Did you smart as well?
No, I know that drink in the trash can.
I start. Because I will put you in your place quicker and fast.
I'm good.
He's good today.
He sneaked this. Nah, say it out loud, bro. I ain't good. What's on your mind, man? What'd you say?
I thought you were in a little altercation in another class, but I want to make sure it wasn't you.
That's all you pointed at me.
Yeah, what you do is in the altercation, not Jameer.
Oh, you talking about with the ball and the water and stuff? Yeah.
He's gonna work for
That was me. I would have been Jack.
Altercation.
Why y'all talk about me? One of y'all want to be like a villain?
Like I was
Hey, let me see this, bro. I don't have a phone. I don't have a phone. You tripping? Bad. Oh man, bad.
All right.
Let me turn it off. Please.
All right. So if we look at the definition.
Well, I will not be able to see it all.
Now, temperature is an average of the kinetic energy. Now, we just studied average kinetic energy, right? It's about, are you done?
Y'all turn it off.
Thank you. All right, it's about motion. Now, you're going to hear me say this over and over and over today. Temperature is about motion. The more motion we have,
the hotter you get.
it's up to you. They're your notice. You know, it's don't make much sense without the question. All right, the temperature is about motion. So think about it. The more you run around, the more you exercise, the more you move, the more motion your particles have. Our bodies are made of particles. Some of us have more particles, some of us have less particles. Okay? So, Our particles move. They are always moving. So, the more they move, the higher our temperature is going to be. I'm aware of that. Now,
I can't see.
now, a higher temperature means our particles are moving faster. So, when you're sick, we've all been sick before. Hopefully, none of you will get the flu this winter.
I bet I had the flu yesterday.
But if you have the flu, you know you run a fever or a temperature, right? If you do, what does that say about the particles in your body? They're moving what?
Slow.
No. If you have a high temperature, your particles are moving what?
Fast.
They're moving fast.
But if you
I'll
cold,
move in a
it's
second. Now, if they're moving fast, that means they're farther apart also, which is why sometimes it's hard to bend your hands
When you're cold.
or you feel swollen,
Yeah,
okay?
that's how it feels right now.
Any of you ever sprained an ankle?
Yeah.
Okay? If you sprain an ankle or a hand and you feel it, it feels how?
Cold. Hot.
It feels hot.
That's my word, bro. When I broke my wrist, it's cold.
Okay, well that could be because of lack of blood flow. All
Hard.
right, but typically it feels hard
It's real
and
hot. Yeah.
okay, because it's swollen.
It's not hot, it's warm.
Okay, warm. Because the particles are moving faster, they move farther apart, and so
We dropped something.
that's what tells us it's swollen. The particles are moving farther apart. Now,
What about your leg on this week?
that's something completely different. Now, if you have a low temperature, which is usually what's happening in here, the room is cold, number one. You guys are sitting in your chairs because you don't get up and move a whole lot. Today is going to be one of those days.
Oh, yeah.
Now, when you sit, your particles do what?
Stay still.
They slow down, okay? When they slow down, what does your temperature do? It feels lower, which is why you tend to feel cool when you're in here. You feel cold when you're in here because your temperature's lower. Now, it also allows your particles to get closer together. Now, those of you who wear rings, do you ever notice that when you're cold, that your rings tend to slide or move easier on your fingers when your hands are cold? All right, that's because your particles in your hands got closer together. All right, your hands actually start to contract. Now, the same thing happens with your feet. If you've ever noticed when you exercise, your feet will expand. Okay? A lot of times, ladies who wear high heel shoes, when your feet get warm, you've been sweating, you take your shoes off. When you go to put your shoes back on, particularly if you didn't have socks on or something, and you try to put them back in your high heel shoes, you're like, dang, my feet don't want to go back in this shoe. All right, particularly if they're very tight shoes.
I'll wear my heels
All the way
tomorrow.
to church. I have several pairs, but you're not going to catch me wearing them here.
I'm gonna find out what church you go to.
All right, does everybody have what they need?
Hey.
Is it the same one as Miss Bowers?
Huh?
Same one as Miss Bowers?
Okay.
All right, now, heat. Heat is different. Heat is different. Okay? Now, the first word that is different in this definition is the word
Oh, no.
total. No.
Throwing it back.
Yeah, but so about married.
I have a liver disease now. Every now and then, but it's rare.
Okay.
That Henny.
Now,
That tequila.
heat is the total kinetic energy. Now, what is the difference, Jameer? What is the difference between the two words? I'm going right back. I'm going right back. Look at what you just wrote down.
Average.
Temperature was an average. Heat is a what?
Total.
Total. So, when we do heat, and I say total, what do you do in math class when I say total? You add them all up. Okay? So heat is a total of all the kinetic energy of the particles in a sample of matter.
Last year, I used to say you was loud.
I am loud.
This year, I'm glad you are.
Right, because some people be low.
Right.
Right. You have.
This walk trying to be all like.
We spell our calls every day.
Yeah, Mr. Stone, he can't teach either. Like when you speak loud, you can't teach. That's like the word. But it's like being loud and can't teach.
What teacher is that teacher?
No, he can't.
Teacher, you can boost off. Right, like you can write one word, and it's a quiz.
Miss Wall, Louis and them got whooped this.
I'm about to snitch.
Louis and them got whooped by some teachers.
That GPA is not even.
Oh, he played basketball?
We played in the game where they got whooped. They lost by
Well, we're
about
ready.
25.
Right.
I feel like what?
Why?
Bro, it was like 50 to 25.
Y'all scored the string itches.
Chris, you played?
No, that is what it is.
Who played?
Football and basketball players couldn't play. It was just like students versus teachers.
So who played?
The only basketball player was like Louis, Isaac, John Webster, Patrick, and all.
Dang, they got beat.
They ain't even trying. They ain't trying.
Mr. Wade and Mr. Taylor, you know, that was looking at.
But what was the teacher?
Yeah, Mr. Wade can play.
Even Coach Luke scored on.
He scored 1-3.
All right, is everybody caught up?
No.
All right, because I want to talk about what I have down there. All right, so what do I mean by more molecules equals more heat? I'm talking about size here. Okay? So,
Why you always got something funny to say?
It's bigger.
that's right. Larger size equals more heat. Shh, guys. So, smaller size. Remember what I told y'all about the answers and the questions? Y'all are not going to know how to answer.
And you're not gonna help us.
I'm not going to help you.
Let's
go. True. Larger size.
That's all you have here?
Now, when we talk about heat,
No, come on, bro.
heat is about size. So yesterday, I said I was going to pick on DeAndre
Please,
in his
Dave.
117 pounds.
Oh my God, he only weighs 117.
What he said. Now,
You ain't got no type of heat.
if DeAndre only weighs 100, I don't think I'm it's a long story.
I got
Don't line up after you don't. Now, if DeAndre only weighs 117 pounds, okay?
All meat.
All meat.
All the heat.
Okay?
Look me up there. I'm 220. Look me up there. I'm 220.
That oatmeal pudding.
All right? Now, if DeAndre weighs 117 pounds and Drew weighs 220 pounds, all right? Who's going to have more heat?
I got all the heat.
All right, Drew has more heat.
The way.
I don't in the way. Now, if we're trapped in a snowstorm, okay? We're trapped in a snowstorm. Shit. If, all right, we need some body heat. We got to shed.
I'm gonna get Phoenix and.
Hold on. You don't get a choice.
Yeah,
No, you don't.
I
You-
get Phoenix.
no, you don't.
I can't leave my-
You only got. Shh. Stop.
I love her. That's okay.
You only get a choice of DeAndre and Drew. All right? DeAndre weighs 117 pounds. Drew weighs 220 pounds.
Damn.
Who do we want in the snowstorm? Drew, because he's got more.
DeAndre.
You ain't got to meet today. Not the snowstorm. Okay? Now, this is where people struggle on the assignment. Okay? Heat is about size. Temperature is about motion. Temperature has nothing to do with size. Okay?
That when black people, like my aunts, be in one car and they be like, oh, it's hot, too many black people in here. That's not why. It's because they some big old lady.
Ding, ding, ding.
I didn't want to say lady.
Now, it has nothing to do with them being black. It has everything to do with them being overweight.
Yeah, I'm here to sit on the porch and it's cold outside and I'm getting hot.
That's because it's sun.
Yes.
Son, don't be out.
It's only sun that tracks.
You ain't never heard of it.
I don't. Think about what you know about colors from art class.
Black is
Yes, black absorbs heat. So he's going to absorb heat out in sunshine.
That means you absorbing all the heat.
Dang.
I'm not saying that's a bad thing.
You know where the heat go to though?
I don't want to know.
So you'll be.
I don't know, but let's not finish the sentence. Do not finish that sentence. All right.
Man.
Now,
I'm about to go stand in front of the sun then.
Man.
Y'all gonna get extra big.
now, look. You don't have to write these in your notes. Just look at the pictures. All right. You got 2 cups of water. One's more full than the other. One has less water in it. One's at 95 degrees Celsius. One's at 100 degrees Celsius. That's nice. Sit down so it doesn't bite you.
Oh, I know.
Which one of those 2 cups has more heat?
100. Because it has less
Because it's
foam.
less space.
It has
for-
95.
What are these blood
Because the
cells?
bottom
or
could be
what?
hotter.
I don't even know.
Heat is about what?
Size.
95.
Who has a look throw away? Who has more water in it?
95.
So the one that has more heat is the one that has more water in it. Okay? It doesn't. The temperatures don't matter.
But see,
It's about which one has more water.
you would think they would be but you think these would be because it's
Doesn't
less? Okay, I want to top these because it's less.
No, he just wanted to touch the board and be all up in it.
Oh, really? I forgot about
All
that.
right, here. Let's do this.
They're closer together, so there will be more body heat.
Which has more heat?
It is.
All right, let's say I have.
And then we get this going, please, while they trying to rest the past. Yes, they are. Oh, no.
I got more. I got you can go look the packets in the trash.
I see a pack in the box.
Nigga, that's my phone in my pocket.
What's your language? I don't like that word.
Sorry.
I don't like that word, but I'm not going to use it. Yeah, I don't like it.
Find a new one.
All right, let's say that those are our 4 examples. And I say, shh, sit down. You're not. I complimented you on your behavior Monday. And
That wasn't Monday.
it was. We're here yesterday. We're here yesterday. Monday. Now, which one has more heat?
You good?
Phony bone.
Hey.
It's not funny, boy.
Now, which one has more heat? Okay? The swimming pool in August. Y'all all been swimming in August? All right? A cup of coffee, a frozen lake, or a hot tub?
Above
All right? How many of you say the swimming pool?
Swimming pool right here. What's up, big
Okay. How many of y'all think the cup of coffee?
That's kind of hard.
Okay.
He is the
Anybody think the frozen lake?
Oh, yeah, that
Wait,
frozen
wait,
lake.
wait.
All right? And a hot tub.
Frozen lake.
Oh, wait.
It depends on how big the pool is.
Swimming pool, we can pick the standard size public pool or like. Alright? Now, why do we pick the frozen lake? Because that is growing. That's right. The frozen lake is gigantic compared to all of the rest of them. It's huge when you compare the pool, the hot tub, and the cup of coffee. Stop beating
But
this
see, the
guy.
hot tub literally is a hot tub.
Okay? When it doesn't matter that the water is frozen. The particles are still moving. There are still millions of them when compared to the other three. So it is massive compared to the other three examples. So it's going to have more heat.
I thought it was
Guys, hush. What?
That's why y'all not going.
Temperature is irrelevant.
We do this activity.
Okay?
Tommy, you call? Where are you?
All right.
Hello?
We need this.
What are you? Hello.
All right. Do all states of matter have heat?
Yes.
Yes.
Radiation.
Shh.
I didn't say no.
Stop. We're not done. We can answer about half the questions at this point. Do all states of matter have heat? Yes. Now, what states of matter am I referring to?
Solid, gas, liquids, and gas.
Okay, solids, liquids,
I got it.
and gases.
What you selling that, Ray?
Now,
All states.
when does motion stop?
Never.
There is a point.
And new
Bruh, it's a law.
When you
It
stop.
never really stops.
friction. Once it is
When
friction.
you die.
When you die.
Be quiet, shut up.
When you do nothing.
You shut up.
Wait, scalar
I know. I feel like
Scalar vector.
When it's the maximum
velocity. Thank you, Max.
It's not terminal velocity. That's when an object that's falling stops moving. Stops accelerating.
after it reaches the next energy, the motion stops.
Oh, I know. When it equals
Bullshit.
When it equals the equator.
Zero.
All right. Have you ever heard the word absolute zero?
No.
You said something about it last week. I heard something about
All
that.
right. Now, Keely said that our motion stops when we die. Now, even when we're dead, our particles in our body don't stop moving. Otherwise, we wouldn't decay and our bodies wouldn't eventually.
Your nerves keep going for
Right. Right. Our bodies still have
That's why our
particles in
nails
them,
still.
and those particles are still
And your
moving
nerves
to
still
some
move.
extent, so that the flesh can decompose and fall off of our bones, and it will still slow down and still move a little bit, but it will not stop completely until we reach absolute zero. Now, what is absolute zero defined as? Does anybody know?
Bones.
Nope, even bones have a little bit.
Soil.
This is 0 Kelvin. Kelvin.
Calvin's.
Now, this is negative 273 degrees Celsius. And unless you know the Celsius scale, that doesn't mean anything to you.
Right.
So it's negative 457 degrees Fahrenheit. Now, some of you this morning, it was about 38 to 40 degrees Celsius. It was 38 to 40 degrees Fahrenheit outside.
Oh, yeah, it was.
So some of y'all were like, man, that's cold.
It is cold.
That's cold.
It has to be 500 degrees colder for the particles in our bodies stop moving, or the particles in the lab counter to stop
So
moving.
let me tell you, I was shaking when I woke up in the morning. It was so cold.
I believe you.
Your
However,
mama to turn the heat on.
It is.
the particles in Phoenix, Jeremiah, the particles in your desk, the particles in your pencil and your notebook, in your breakfast this morning, in your bodies, all of those particles are moving. They don't stop moving until what happens?
You're dying.
No, they still move when you're
That's
dead.
zero.
Until you reach absolute zero.
Which means they're frozen.
This is moving.
Yes, the particles inside of that pen are moving. They're vibrating.
How?
No, it's not. I don't feel any vibration.
How you get to absolute zero?
You have to increase the temperature, lower the pressure.
How
Did
can I
you ever watch like Bill Nye Science Guy? Dude, when I ask a question, we don't have to get loud. Do you remember seeing him show experiments with like liquid nitrogen?
Heck yeah.
Okay, remember he put this stuff in and it came out and it was completely frozen? Okay, that's still not absolute zero. That's pretty cold, but it's not absolute zero.
How you get to absolute zero?
You have to lower,
You gotta go to Antarctica.
absolute zero is a theoretical value. We've never gotten absolute zero.
Absolute zero. I'm gonna eat good.
I'm glad you good, alright.
Alright, now,
I brought Chinese.
the last thing we need for our lab today,
I got you an inch of
really it's just coloring today, but still. Why do some objects stay hotter longer than others?
Because they got more molecules.
Not a bad answer, but it's not right. Not bad though. Alright, y'all got it ready?
No.
Yes.
Y'all got it ready?
The
We're
way
gonna
it's
put some
shaped.
assignment today.
Is it by the way it's shaped?
Not by shape.
Size.
No. Not a bad answer though.
These stay.
Jameer, grab the count. Sit on the stool. Alright, why do some objects stay hot longer than others? Or why do some objects heat faster than others? Have you ever noticed, Keely? Have you ever noticed, for example, that you put aluminum foil in the oven
Yeah,
and you can almost instantly pull it off something and it's cool?
yeah.
Okay? Why does aluminum foil cool so fast?
Because it's thin.
Alright, it's not because it's thin.
Yeah.
Alright, if you put water on to boil, it takes a long time for the water to heat up. All metals are conductors.
Radiation.
Microwaves are quick by radiation, not based on heat.
Then why would it blow up?
Because it's
Because
not
it
heat.
reflects off of it. It bounces the microwave rays around with the microwave.
You so smart. Why you love
And don't put your phone in there to charge
Hey,
either.
you know if you put a grape in
A friend of mine texted me that a middle schooler did that. Not a good plan.
grape.
Their phone in the microwave.
In a microwave.
It doesn't charge in the microwave. You thought it did.
It'll break your microwave.
Huh?
What do you do? Turn the microwave
Come on, look at
No, it
that.
blew up his phone.
Because it's on
on? Say
fire.
you turn the microwave on.
Yeah, he put his phone in the microwave, programmed it for like 30 seconds to charge his phone.
No, I tried.
Blew up his phone.
He's a freaking giant.
Yes, he
Yeah,
is.
that's right.
What school?
Middle school.
Ours like 98.
It's a middle school.
I'm not gonna try.
It's not.
Hey, middle
A friend of
school.
mine teaches
How do you make fried Oreos?
We put it in the battery and fry.
Yeah. You probably had a Maria phone.
Put it in some cake. My camera was good too. No, I can show you some pictures. My pictures was good, and they are
While you
good.
were back there, I'm
Let's
pretty
not.
sure fried Oreos.
We're not engaged in the class.
Now,
Class discussion.
so why do some objects heat faster and cool faster than others?
Because they got
Okay.
more molecules.
It has to do with a different specific heat. Not all materials have the same specific heat. Okay? Now, specific heat. You do not have to know the definition. Okay? So you don't even have to write it down. Alright? Yeah, you better write it down. I can't remember if I put it on the test. Dr. Phillips and I may have put it on the test, so you better write it. Just in case I'm wrong.
Wait.
Wait, the middle or the
The
bottom?
bottom. You need the whole page.
Oh.
The top half is on the assignment today.
I'll just do the bottom.
The bottom, I can't remember if it's on the test. What? If I ever watch Dinosaur Train,
We gotta test this Friday.
it probably won't be Friday. It'll probably be Monday. Say what? It does not ring a bell for me, no.
About City Science Kid.
I've seen Science Kids.
I like him. He used to make good songs.
Sing that.
That boy old right now.
What?
Chris, you got your notes?
Hey.
Deandra, you got your notes?
Yeah, I got my notes. Got my notes. I'll write that notes. I never. I have one question about everything. I was at home. Man, I was like fifth. I think third.
Alright, have we caught up?
No.
We go to fifth one.
Alright, so specific heat is just defined as an amount of energy. Okay, and we've been talking about energy. So it's just the amount of energy needed to change the temperature of an object 1 degree. Now, these temperatures that are needed to change that 1 degree are already measured. They're on a table, okay? You're not going to have to know what these specific heats are. That's not important to us. We're just going to look at a couple and talk about why some are low and some are high and what it means, okay? And we're going to use some examples of things you know, like aluminum foil and water, because everybody's used aluminum foil maybe to wrap around bread. Maybe you're like me and you don't want to wash a pan, so you put aluminum foil on the bottom of it so it's easier or you don't have to wash it.
Listen.
I admit that.
That's how I feel like it's time to girl.
All right, everybody got what they want. Serenade you, coming through. It's priceless. Hey.
Get on the beat,
Alright. So,
He said you ain't there since last Wednesday.
you had these.
You said you gonna catch.
Alright, so looking at water.
Come to the bathroom, please.
Nope.
Pretty please.
Nope.
With some cherries on top.
Nope.
I'll stay for 20 minutes.
Nope. Alright, so water has a high specific heat. Now, you need to write this down because this is the part that's important for your lab today. Now, these have low specific heats.
Now, come to the bathroom for real?
No, sit down. Now, what does it tell us if water has a high specific heat and something like aluminum foil or copper has a low specific heat?
Water has more molecules.
All right, what? Not necessarily, because I could have a small sample of water and have a small sample of aluminum foil. Okay? Does water heat quickly or does water heat slowly?
Slowly.
Okay. Something that has a really high specific heat means that you heat and cool very slowly. For example, yes, that's the important part for today. If we went to the beach in March or April or spring break,
Cold.
that's right, the water's going to be cold. We would not want to get in ocean water and swim.
Some people do.
Some people do. I think they're nuts.
They're from like Canada.
Yes.
Hey!
I get it. What you talking about?
All right.
I ain't never been to the beach. I ain't never been to the.
Now, back in the middle 90s, we had a couple Canadian teachers who taught here. And when we had spring break in March and April, yes, when they went to the beach, they always got in the ocean in March and April. All right, they never minded the water temperature. It didn't matter if it was in the 50s or the 60s.
There'll be a question on the test, like which one he took.
Which one, what?
There'll be a question on the test, like which one he took.
Which one is?
He took fast.
Not which number, but there might be a question about.
It was like, which one he took fast.
Devin, stop telling me what's false. Stop. Jermaine, you yes. I'm getting ready to look it up there. I haven't got it.
I know
Now.
you proud to keep it there.
Chris. Now, when you look at ocean water in the fall, could we go to the beach right now and walk along the beach and stick our feet in the water?
Yeah.
Yes, because it's still warm. It takes water a long time to heat up and a long time to cool. If you remember Earth Science class, hurricane season runs from June the 1st all the way through
November.
the end of November because the water stays warm all the way through the end of November. Okay? Because water has high specific heat because it heats and cools so slowly. Now, low specific heats mean what then? They warm quickly and they cool quickly, which is why when I bake bread in the oven and I warm it up, if I want to pull it out of the aluminum foil, do I need mitts to pull the foil off the bread?
No.
No, once that aluminum foil gets away from something hot, all I have to do is literally pull it away and it's fine.
What's it called? What's a penny metal?
So what?
Yeah.
A copper penny is really not made of copper anymore. They stopped making pennies out of copper back in, I think, the early 40s because now if a penny was made of real copper and only copper, it'd be worth more than a penny. It's largely made of zinc.
He doesn't know what
It's still gonna
money.
You can't do it
So if I
metal
find a
like-
copper penny, I can sell it.
Yes, it'd be
But
worth.
you're not gonna find it.
I don't know that you're gonna make a great deal. Stop that.
I give you this one penny for $1,000.
Coin collectors would probably be
Alright,
interested in this because it's made prior to 1940, whatever.
I said my own thing. I was locked up in my own thing.
All right.
Put them in the cage.